This is our last lesson really for this week, according to plan anyway. And we're looking at group data. Okay, so we've got, in this case, this is, by the way, it's exercise 7, but I'm doing the examples on page 239. And they collected data there about average height. So they looked at average height of people in the country, and they said, okay, how many countries do people have an average height between 150, including 150 centimeter, 1.5 meter, to 155. And they found out there's 12 countries where that's the average height. And then how many countries have average height between 150 and 160? There's 50. Okay? Now, quite a few things to say here. Okay? First of all, this is a continuous data. What is continuous data as opposed to discrete? So continuous data, like height. Let's say I'm 1.76. That's 176 centimeters. Another person is going to be 177. Can there be somebody in between us, 176.5? The answer is yes. So height is a continuous data. Okay? Mass will be the same. But if we look at, for example, number of goals or number of wins a team had in a season, okay, rugby season, how many wins you had? Well, you can have 1 or 0 wins, 1, 2, 3, 4. Is there something between 2 and 3? No, there's no half or 1 win. It's either you won or you lost, or you tied, but either you won or you didn't win. So when we count 1, 2, 3, and there's nothing in between, we call it discrete data. Okay? So when we have continuous, we have to, we'll come back to that in a minute. I maybe said it a bit too early. But one thing you're noticing is here that we always have the way we write it. So x, the height, it's larger or equal to 150 and smaller than 155. There is no equal sign here. Why is that? Because if you are actually 155, that's the average height, then you're in the second bit, okay, in the second, what we call class, okay, so now we'll talk about that, okay. The average height in this case is what we call the class interval. So in a different example, it could be how many students have an average between 50 and 60%? How many in this school? How many students in this school have an average between 60 and 70? So 50 and 60, 60 and 70, 70 to 80, that's all going to be class interval. That's what we call it. An interval is like a chunk. Okay? Now, on this case, the number of countries, that's the frequency. So how many countries? Okay? Now, if we were going to draw graphs, okay, which we're not, but I'll just quickly go through it, then we will draw it here. We will have the average height, the class intervals here. We're going to have the frequency over there. I'm not even labeling it. Okay? And then we're going to start drawing bar graphs. Okay? Now, would the bar graph touch each other or not? Okay? Are they going to touch each other or not? And now, because it's continuous data, then they need to touch each other. Okay? So 150 to 155, we've got 12, so I'm going to do a bar that goes up to 155. 155 to 160, it goes all the way to 15, so something like this. 160 to 165, 19, just a touch before, they need to touch each other, touch before 20, like this. Okay? So we're drawing this, not bar graph, they're touching, the bars are touching, okay? Okay, but this is not what we're really interested in today. We're interested in calculating or finding out the modal class and the estimated mean. Now the modal class, let's start with the easy one. Modal class is easy. What is mode? Okay, we spoke about mode. Okay, mode is the value that repeats itself the most. So modal class is the class, the interval, that has the highest frequency. So I didn't draw the whole table. You can look at the rest in page 239. But we actually included the modal class. This is the modal class. But the answer is not 33. 33 is the frequency. It's the highest frequency. So the modal class is x larger or equal to 170 and smaller than 175. Okay, so that has the highest frequency. But you need to quote what is the modal class. That is the class. That's its frequency. That's the class. Okay. All right, moving on to a bit more difficult, and that's how to calculate the estimated mean. Now, let's just think about it. What is mean? Okay, mean means that you are adding up all values together, divided by the number of values altogether, and that's it. Okay? Now, why are we calling it estimated mean? Well, we call it estimated mean because we can't actually calculate the real mean. Because I'm told, for example, that there are 12 countries where the average height is between 150 and 155. But I'm not told if, let's say, one country the average height was 150 and the other country was 151, and there was another country here that was 154. Okay, I don't know the actual average height of the countries. So I can't just add up all the average heights of all the countries and divide by the number of countries. That's how I would calculate the real mean. If I want to know the mean height of the people on planet Earth, then I will take the mean of each country, add up all the means of all the different countries, divide by the number of countries. Even that actually is not accurate, isn't it? Because one country, let's say South Africa, have 55 million people, and in China there's like 1 billion people. I can't just add the means as if they're the same. They're not. So really I should add up all the heights of all the people in the world, divided by the number of people in the world. But let's leave that. I can't do that anyway. So what do? I'm just going to pause you here for a second. Oops, sorry guys, I didn't pause properly. Okay, so I've been wasting a little bit of your time. Sorry about that. Okay. Luckily I didn't say anything embarrassing. Anyway, so how do we calculate the estimated mean? Okay, what we're going to do is write down the midpoint. Okay, it will make sense in a bit. What does that mean? What is the midpoint of each class? Is the value that is exactly in the middle. So I'm going to start by calculating it, but then you'll see it easily. It's going to be 150 plus 155 divided by 2. So in other words, I'm finding the mean of the interval, okay? So that's going to be 152, 5, okay? I think for the rest we can do it on our own, right? It's going to be 157, 5, 162, 5. Pause you here for a second. Okay, so I've magicked the rest midpoints, the fraction of a second, and how am I going to help that? Okay, what you might think, you might say, okay, if this is like the mean of the average class, if I want to find the mean altogether, the estimate mean, maybe I need to add these values, because that's the middle value of this class, this is the middle value of this class, this is the middle value of this class, and so on, so on, so on. So can't we just add them all up, add all these values, and then divide maybe by the number of countries? I think I've got altogether 135 countries. That's the total. Okay? But obviously I'll be wrong if I do that. Because let's compare this class to this class. Okay? Now, if I just add 172.5 plus 182, I treat them as if they're the same number. The same number of people in this class and that, same number of countries. But obviously that's wrong. There's many more countries here. There's 33 countries here, only 9 countries there. So this value, 172.5, should have a bigger weighting. The word we say have to have a big weight. Okay, we need to give it more weight. Okay, the class intervals with the higher frequency have to carry more weight than the class intervals with lower frequency. And how do we do it? What we do is we calculate the weighting. And the weighting is the frequency times the midpoint. So I'm going to do 12 times 152,5, which is equal, I'm just going to copy that, 1,830. Then I'm going to do 15 times, I'm timing the frequency, the number of people, number of countries in this class interval, time that mean of that class interval. It's not the mean, it is the mean of that class interval. So 157,5, okay? Pause here for. Okay, so I magicked all the rest of the number. Look at that. Every time, all I did is time the frequency, time the midpoint. Frequency, time the midpoint. And I'm getting your weighted mean for each class interval. Okay? Now, this is the reason why it's very important for all these tables to have a total row at the end. Okay? We have the total frequency. We added all the number of countries. We got 135. We don't need to add the midpoint. That's not a problem. What we got to add is the frequency times midpoint. And I got 22,707.5. Can you now try and guess, how do we calculate the mean, or estimate it? Okay? Pause me for a second. Think about it. How are you going to calculate it with these two values? Okay? I think some of you did guess right. Okay? Right? What you got to do is you got to take the total weighted values. Okay, you're going to take 22,707,5 and divide it by the total frequency, 135. Okay, I'll write like a general thing. What you got to do is you'll divide or sum up the total frequency, or let's put it not total, we'll call it sum of frequency time midpoints. You sum them all up, and you divide it by sum of frequency. Okay? And in this case, I got something like, what did I get? 168.20. So we got 168.20 centimeters. Okay, so that was my estimated mean. Why is it estimated mean? Okay, remember, because we don't know the actual means of each country. It's just an estimated. I said that the estimated mean for that midpoint is 152.5. Okay? But I don't know, it could have been more or less. Okay? Now, before I set you loose on these questions, there's nothing difficult. Like I said, stats, it's a little bit, you do a lot of work, but it's not very hard on the brain. Okay? There's one little issue, which we're probably not going to come around with a lot, but mentioned in the book, so I might as well do it, and that's about discrete data. In this case, the average height we treat it as a continuous data, because you can have 150.1 or 152.3. So the values in this class intervals are anywhere between 150.0, because it's including 150, but it doesn't go up to 155, because 155 is already in the second class interval. So it goes anywhere between, I have space here, between 150.0 all the way to 154.99999. Even if you're 154.99999, you're still in this class, not in this class. Okay? Now, if that's the case, because it's continuous, then the midpoint will, I'm right to have done this. I did 150 plus 155, because 154.999, we round up to 155, so the midpoint is 152.5. That's true. Well, what if I treated the height as discrete, okay, which actually we often do? So I don't know if I'm 176.3 or 176.4. Most of you guys will just know, are you 176 or 177? 175, 152, whatever it is, you don't know the point. So we are really normally looking at height. In theory, it's continuous, but in practice, we treat it as a discrete data. So if we only collect discrete data, then the real options that in this class interval, in this case, if we treat it as discrete data, the only possible values will be 150, 151, 152, 153, and 154. These are the only values that could fit in there. Yeah, I wouldn't have 154,999 because we're just looking at discrete. If we're looking at discrete, we shouldn't here, but maybe there's another question where it will be discrete. Now in this case, what will be the mean of these points? Okay, in this case, it's not going to be 152.5. Okay, you can add them all up. Okay, you will get 152. Okay, you can actually see it quite clearly. That is the mean. Add them all up, 150, 151, 152, 153, 154, divided by 5, you're not going to get 152.5. You'll get 152. Okay, so you got to watch out. It's a bit of a subtlety. If you're using discrete, then the midpoint is not going to be the same than if it was a continuous. Right, that's it, guys. You just need to do the questions there. I had a look. There's nothing really major there. It's just doing the work. Okay? See you guys when I see you.